Hello, I'm Dr. Heidi Brumbaugh, creator of the Vocab Victor word learning app, and this is a video of a talk I gave at Carnegie Mellon University for the CALICO 2024 conference. CALICO is a conference for computer-assisted language learning, and there's lots of developers there, teachers that use the software, and research on best practices for computer-assisted language learning. And the idea for this project actually started at CALICO 2023 because I saw that there were all these rich and wonderful language learning apps. There were, chat bots, there was language exchange apps, task apps, translation apps, elicitation apps, and it seemed that although there was this great variety, each app was its own island. And from a student's point of view, they might go from app to app, but there wouldn't be any sort of coherence or integration with the things that they were learning in their classroom or the things that they learned in the other apps. So I started thinking about a way to hook the apps together. So I'm going to start out by talking about what a learner model is, and then I'll go into word knowledge and talk about how we might operationalize this model in the modern call environment. Finally, I'll show you some early results. So the learner model is foundational to iCall, which is intelligent computer-assisted language learning. And if you're doing call software without that little I in front of it, you are squandering the power of computers to remember what a learner did, to keep track of a learner's progress, to predict what they might do next or what might be the best thing for them to do next. This is a quote from my mentor, Trudy Haidt. A learner model is a description of the learner's knowledge and, in the context of intelligent tutoring, its main goal is to guide pedagogical decision making. So here's another take on learner models, and this is back from 2008, which was a while ago. But Trudy here is talking about the ultimate goal of creating an individualized learning experience, which is still a buzzword. Everybody talks about personalized learning. The learner model is the way that you can get there. So there is different types of learning that might happen, about different types of approaches we might take once we have this model. We can use it for evaluative, like formative assessment, predictive model, strategic, but it all comes down to a single critically important question: which words should the student learn next? This question is important because pedagogy, in the words of everybody's favorite educational psychologist, Levi-Vygotsky, pedagogy must be oriented not to the yesterday, but to the tomorrow of the child's development. Only then can we call to life in the process of education those processes of development which now lie in the zone of proximal development. And I love the evocative language here and the idea that the student, the child, the learner has a certain amount of knowledge, and you can imagine that there's something that they can learn next that is perfectly scaffolded, to use the word from modern educational technique, perfectly scaffolded for that student. So which word are they most ready to learn next? What are the things that they already know that will help them learn that next word? And the reason we need this is because language is very large and time is short. When we're talking about vocabulary, we're talking about tens of thousands of words. And when we're going to teach vocabulary, which is hard to learn and hard to remember, if we're not giving the student a word that is useful to them, if we're not giving a student a word that they have the tools to remember, if we're not giving a student a word that is helpful to them in the sense of, being present in the things that they're about to read or whatever, then again, that time that is being spent teaching and learning and studying is squandered. I'm going to talk a little bit about word knowledge here. Second language vocabulary acquisition is my nerdy obsession. There's not very many of us in this field, probably a couple hundred all told, but we look at this at a very deep level. So, a layperson might have the idea that to know a word is to know its meaning, and this is generally true, but according to Norbert Schmidt, one of the leaders in the vocabulary field, the mental lexicon is a complex phenomenon, and the exact nature of lexical knowledge has always perplexed researchers and teachers. Oh, a lot of this is kind of ephemeral. It's hard for us to understand, it's hard for us to quantify, but some things we do know. One thing we know for sure is that word knowledge is multifaceted. And this is from Paul Nation, who's really kind of the leader of the modern vocabulary research community. And he started this in the 90s and 2001 with this idea that you have form knowledge. What does the word sound like? How is it pronounced? What does it look like? There's meaning knowledge. What's the meaning of the word? What's the definition of the word? What's included in the concept? We talk about polysemy, multiple meanings for a word. What other words are associated with it? What are synonyms of the words? So meaning is in here, and I want to talk a little bit about the next section, use. What is the grammatical function of the word? What are the patterns for the word? What are the collocations? And, when I say I'm a vocabulary nerd, one of the things that means is that I kind of go through my professional life with a vocabulary learning hammer, and I see all language acquisition problems as vocabulary nails. So people that might cry, well, what about grammar? What about grammar? I think that one of the benefits of teaching vocabulary is that part of vocabulary knowledge is grammatical knowledge. It's usage knowledge. It's where in a sentence would this word be? What are the collocations of the word? So if you're teaching that stuff, you are grammar adjacent. It's definitely, it's not central to this model, but it can be captured by this model. The other thing we know about word knowledge is that it's incremental, and I love using this quote, this citation from our old friend Dolch of the Dolch Word List. It was because he noted almost 100 years ago that we don't go from not knowing anything about the word to having this rich, multifaceted knowledge about the word, but rather that knowledge builds up over time. And as such, when we're thinking about a vocabulary learner model, it's not a fixed construct, but it's a living thing that evolves over time. So how can we operationalize that in a model which is going to be captured in a computational system? So the first thing I started thinking about in developing this project was to use the research from Paul Nation and others' work to develop a taxonomy of learner knowledge. And if I can do that, I was able to break down a learner's engagement with vocabulary across multiple dimensions. When I say that, it's like each time a learner encounters a word in an app or, even in a classroom or in a reading, multiple things are happening. There's the modality for the word, for the engagement. Was it in text or was it in speech or was it in sign? What was the context? Was there a cue here? A lot of activities have to do with translating a word or knowing the definition for a word, knowing the associations for a word or an image. So we need to know what was the context for this engagement. What did they do? What was the interaction? Was it a match? This is a common activity for multiple choice tests, for example, or a lot of the games that I make are match activities. You could also make tracing, like finding the word in a puzzle, studying, straight up studying a word, producing a word. And related to that is a taxonomy element called directionality, which is based on some research by Batya Laufer that I'm a big fan of. So this is, did they match or produce the target word, or did they match or produce the cue word? There's actually two different types of knowledges that are happening here, and they are related but not the same. So I'm going to give an example of mapping this taxonomy to an activity. This is a game in my app, Vocab Victor. The game is called Word Strike. I have a target word that you want the user to learn, in which case it's literally a word on the target, which is steal. And then there's potential matches on the arrows. So take, different, grandmother, summarize. And in this case, the correct answer is take, which is a synonym for steal. So if we wanted to quantify this, if we wanted to identify it as a taxonomy, we could say the target word is steal, the modality is text, the cue is a synonym, the interaction is match, and the directionality, this isn't obvious, but the directionality for steal is actually passive because we're not choosing steal, we're choosing the match for steal. In a surprise twist, for the same activity, you could make another observation that there was also an engagement for the cue word of take. And in this case, the modality is still text, it's still a synonym, and it's still a match. But in this case, it's an active action that the learner took. So the learner had to choose take from these other options. So for one screen of this game, one round of this game, you actually have two vocabulary words that had two similar but slightly different interactions. So how do we operationalize this in the modern computer systems architecture? The first question is, where do we store the data? And the most obvious answer turns out to be in the cloud. There exists right now, we're very fortunate, I think we're developing this project at the perfectly right time in terms of computational systems that are available to programmers. And one of them is these cloud-based databases, these cloud-based systems that allow us to manage huge amounts of data without having to actually manage the network ourselves. So all of our services are used on Google. So we have Google Cloud Functions, we have Google Cloud Databases, we've got SQL servers, we've got document databases, and all of these, and we've got Google authentication. I mean, all of this stuff is stuff that is built for us and is supported for us, so we're able to kind of get into the details without having to spend too much time on the plumbing once everything is set up. So the way this will work in practice is that the user will have an interaction in a language learning app of some type. They'll choose a word, they'll perform an activity, they'll play a game, they'll write something, they'll read something, they'll click on something. Each interaction with each vocabulary word is encoded using the taxonomy that I just discussed. And then our application programming interface takes that encoded interaction and installs it onto our database. So this happens a lot. We end up with millions of data points, and once the data is in there, our analytics engine is going to go in and kind of crunch the numbers, use statistics and machine learning algorithms and math and rash modeling, all different sorts of techniques to kind of squeeze the most out of as we can out of that data. Then that will generate for us what we're calling zone words, which are words in that zone of proximal development, which then you can call the API again and get the zone words for the learner and send it. Then you know what to show them in the app because those are the words that they're just ready for. One of the things that's specific about zone words that's really important to this system is that it gives you the probability of success for a certain task. So zone words are always associated with one of the activities in your app. So I want to give an example of how this could be used across multiple applications. So let's say that in one application, a learner has encountered a word during a reading assignment. That word, once you've seen it once, it might be recommended for, let's say, a game that involves matching the word to its meaning. So again, like Dolce says, we're building it up. First, have a little bit of knowledge about the word, and then just build it up a little more. It's like, okay, you kind of know this word. Maybe you can guess what the meaning is. Once they've demonstrated that passive understanding, the model will suggest the word within an elicitation app that has kind of the next level of production. So we want them to produce the word. As soon as that's happened, we know that the learner is already proficient in the word. So at that point, we can divert their attention to other vocabulary. The other thing I want to talk about here is a diagnostic research, a diagnostic usage application regarding reading thresholds. And I said that, the vocabulary scholars are a pretty serious lot. We do a lot of research, and one of the things we've studied a lot is how, if you given a text, what percentage of the words in that text should be known to the learner. And one thing we know for sure is anything below 80%, which is to say if they only know 80% of the words in the text, 20% are unknown, it's too hard. I mean, they can't do it. They'll get frustrated, they'll give up, they'll look up every word and forget the beginning of the sentence. It's just too difficult. You have to have a minimum of 90% were known words in order to just get through it and kind of get the gist of it. Once you get to a higher level and have about 95%, you can guess the meaning of new words. And this is what everybody talks about with reading, is that learners pick up words from reading. It's not a magical process. They have to know enough of the surrounding words in order to have clues that will help them correctly infer or guess the words. When they get up to 80%, you can read for pleasure. So the exciting thing about a project like the vocabulary learner model is you could feed in a piece of text. A teacher, for example, could feed in a piece of text and the learner, and then it would analyze it and say, okay, this learner knows 75% of these words, or this learner knows 95% of these words. And then the teacher can make a decision going forward, okay, this piece of text is too difficult for this student, but it's just perfect for another student. And then take the same text and maybe run it through a large language model, something like ChatGPT, and say, simplify this text, or, write this text, but use synonyms for the following words that the learner doesn't know. So this could be a very, very powerful tool for delivering personalized learning for students that will help them. And the goal is always to get the most out of their study time. So I've been working on this project for a little over a year, and I have some early statistical results that I've gotten from putting all the data from my my Vocab Victor app into the software. This is an observation for matching words to associated words, and the precision is pretty good. It's about from 83% to 99% accurate. The statistical results, this is a logistical regression, and the interesting thing here is both that it tells you how much each of the previous encounters with the word contribute to how well they're likely to know it. And the other thing is that this could really help vocabulary research. So I say, interesting, if we know other associations, we're more likely to know new associations. But the synonyms, if we've seen synonyms or definitions, it doesn't weigh as much into this activity. So this actually might be a research tool for kind of figuring out a little bit how these different word knowledge types interact to build up a structure and make it, to use Norbert Schmidt's word, less perplexing. And we can pull up a list of zone words for this activities and say, for example, that they're more likely to know the word day than, they're more likely to know the word large than huge, which kind of makes sense because large is a little bit more common. Um, so those are the kinds of questions that we'll be able to answer using this tool. I'm really excited about this product. I'm calling it Vocab Victor Zone in homage to the zone of proximal development, and we're tightening up our APIs and all of our systems. So we will be rolling that out hopefully soon. If you want to be an early adapter or learn more about it, feel free, or just chat with me about it. I can talk for hours about this stuff. Feel free to reach out, and if you want to see the slideshow, I have added it to my Google Drive. Thanks for your attention.